Welcome to our presentation. My name is Betsy Pillow, and I am here with my colleague, Jessica Hernandez. We are honored to be able to share with you today. The theme of our session is building a computer science classroom community. We are both looking forward to sharing with you information about how to build a classroom and school culture that encourages and supports computer science education. The information in this session can be adapted to any classroom from preschool through high school.
Today's session focuses on the strand of foundational concepts and the impact of computing. According to Gallup Amazon, that was featured in 2021, there will be a 22% projected increase of computer science jobs in the next 10 years. The Bureau of Labor Statistics states that 67% of all STEM jobs are projected to be in computer science.
I currently serve as the STEM and PBL coordinator and the STEM committee chair at the University of Memphis campus school located in Memphis, Tennessee. Our school is located on the University of Memphis campus. I work with teachers and community partners to plan and implement STEM and PBL units and events for the school. I facilitate a group of 4th and 5th grade student leaders, which are called the Campus School STEAM Ambassadors. And this small group of students meet with me to plan STEM activities for the school. I was born in Memphis, and I've graduated from the University of Memphis with a bachelor's in elementary education, SPED, and a master's in STEM instruction and curriculum. This is my 7th year as a teacher at campus school, and prior to teaching at campus school, I was a special education teacher in the Memphis area. My favorite thing to teach is environmental science, and I love using novels and trade books to teach science. My favorite is One and Only Ivan. When I'm not teaching, I love spending time with my family and friends, spending time outdoors, and baking and cooking new recipes.
Hi, I'm Jessica Hernandez. I currently serve on the central team at University Schools as the coordinator of teaching and learning technologies. In my role, I support students, families, and faculty with equitable access to technology-based resources and professional development. In addition to that, I also teach a computer science elective for middle school students at our university middle school for grades 6 through 8. And I spearhead an extended learning program at campus school, which is Girls Who Code, for grades 3 through 5. Girls Who Code focuses exclusively on closing the gender gap in technology use. This is my 13th year in education. Before stepping outside the traditional classroom, I taught math and science in a STEM setting for 11 years, mostly serving grades 4 through 7. But I've served also grades all the way from 1st to 8th. I'm a Google certified educator and innovator. I hold a master teacher certificate through the National Academy of Advanced Teacher Education, and I'm a lifelong Tiger. I have a BS in education from the University of Memphis, and I have a master's in educational leadership from Arkansas State University. In the fall, I'll start a doctoral program in educational design and technology. Before we get started, we'd like to tell you a little bit about where we come from. So we both serve for University Schools. University Schools is a set of laboratory schools that's located on the University of Memphis campus. We are a set of public schools, and we have very specific and unique identity. At campus school, it's primarily a lab-based school that focuses on STEM instruction. Our middle school focuses mostly on PBL instruction, and we also have a high school that focuses on adult enrollment. In addition to that, we serve pre-K at our Early Learning Childhood Academy, and they have a Montessori approach to learning. So we're very unique in our mission, and basically we operate in partnership with our families and our communities. We have 3 core values: celebrate, cultivate, and prepare.
As STEM leaders, when we begin to create and facilitate a computer science culture in our schools, we believe there are 2 guiding questions to begin this transformation. These 2 questions are designed for you to take back to your teams to encourage authentic discussion about what computer science currently looks and feels like from the student and teacher perspective. So that way you can create an authentic snapshot of what you want it to look and feel like. The 2 questions are, As educators, how can we better understand the impact of computing on our classrooms? And what does computer science education look like in our classrooms? These questions should be presented to students, families, teachers, and community partners. They should be responded to thoughtfully, and there should be authentic follow-up conversations about the responses as your teams build the computer science programming.
So we've broken down big computer science ideas by grade, and these all stem from computer science standards for Tennessee. So basically, you're going to start with kindergarten. They're going to start with really basic introduction of using a keyboard and a mouse, learning about a trackpad, things that follow sequential order. They're going to learn internet safety, the ins and outs of what to do and not to do on the internet. In our first and second grades, they're going to focus on appropriate desktop icons. So they'll learn to feature things based on like identifying a picture or a particular icon of a particular program. And they're going to start looking at selecting technology tools to solve a problem. In our third and fourth grade, they use digital tools to communicate big ideas. So they're going to start working on like Google Slides and displaying info. They're going to learn basic develop code to solve a problem. So if I press this button, it's going to do this action. They can explain basic hardware, and they're going to use advanced keyword searches. In our fifth and sixth grade, they use advanced features of digital keyword searches. They're going to talk a little bit about copyright principles, and then they're going to develop and start to recommend solutions to solving basic tech issues. In seventh and eighth grade, they're going to apply computational thinking. So the research skills are going to be a big part of that. They resolve using appropriate troubleshooting, so they know how to get in and out of a browser, how to restart a computer, things of that nature. And then they're going to learn a little bit about digital globalization, internet censorship, and the laws behind that. And then at our high school level, they're going to start to create prototypes like 3D printing. This is where it comes into place. They're going to simplify those solutions. They're going to identify implications of technology laws and how that applies to them as adults in the real world. And then they are going to really become experts at research, designing things and developing.
Each year, our STEM committee, which is comprised of teachers, parents, district leaders, and community partners, creates a document we call Year-Long STEM. The purpose of this document is for school stakeholders to create a comprehensive calendar of the STEM events, so that way we can ensure we have all of the domains of STEAM covered, have formal and informal STEAM activities planned, have STEM events that appeal to all of the grade levels, and also ensure the heavy lifting is spread across the members of the STEAM committee. Here's a list of some of the technology special events from this school year's Year-Long STEM. Hour of Code is an event in November, December. And for this event, Jessica and I partnered with our elementary school media specialists to create station rotation activities for the kindergarten through fifth graders. Each grade level had stations with computer science activities that matched the level of expertise and interest of the students. We had parent volunteers come in to assist with the lower elementary grades. STEM or Tech Nights is a school-wide initiative that gets students, families, and community partners involved in STEM initiatives. By holding an event like this outside of school hours, it opens up the possibility of bringing in community partners who may not be available during the school day. This also allows families to experience STEM and technology with their students. Career spotlighting is incredibly important for students to become immersed in a positive computer science classroom culture. For each STEM calendar event, we intentionally spotlight a STEAM career. Creating these experiences for students to explore careers strengthens motivation and informed decision-making skills when it comes to careers in the STEM fields. Having the opportunity to teach a computer science course is a wonderful way to build the culture of computer science. At our middle school, students are provided the opportunity in grades 6 through 8 to learn about problem solving, physical computing, user-centered data design, and data. If you're looking to build culture through informal learning environments such as clubs and organizations, this is a wonderful way to build interest for students. Girls Who Code is a club that's offered for 3rd through 5th grade. Girls Who Code is an initiative whose goal is to close the gender gap in technology-related fields. Providing opportunities such as Girls Who Code can be critical if your computer science culture is lacking diversity and inclusivity. To build a computer science culture, students must see themselves represented in these STEAM fields. Jessica hosts a tech team for students in grades 6 through 8 to provide them the opportunity to experience technology during the school day. And I host a STEM ambassador program to give students the opportunity to build their STEAM leadership skills among their peers. Across the university schools, teachers work collaboratively to create being there experiences. These experiences are guest speakers, field trips, and field experiences. These opportunities deepen work readiness knowledge, help students develop technical knowledge and skills, and strengthen industry connections between teachers and their investors.
When it comes to technology integration at your school, you want to start with building the norms. And so here are some norms that we have selected that I've worked across our schools. So we suggest building or joining a STEM committee or a technology committee. Campus school hosts a very robust STEM committee, which meets regularly to discuss upcoming events. Attend some professional development. There's a lot out there, so just do a little bit of digging. Survey your students, teachers, and community partners. Every year, university schools send out 2 surveys, a tech needs survey and a STEM needs survey. And those help identify where we need to go and what we need to do. Collaborate with others across grade levels and schools. Betsy and I are not featured in the same school. I work on the central team in a completely different building. And while I'm routinely at campus school as a part of my genuine job, I'm not there all the time, but we do collaborate among each other and with other partners. And then create check-ins with focused agendas and goals, and determine what will work best for you.
Finding resources can be an overwhelming feat. One important thing to remember is that no matter where you are starting, there are opportunities for computer science education. You do not need to have robots and iPads to build a culture of computer science. For example, if your school has access to recycled bottle tops, your class can do an activity about computing and patterns. A classroom could collect Legos from families to build a Lego collection for the teachers to use. Both of these are examples of computer science that can be built into your school culture and goals. If you are seeking materials you do not currently have, grants are an awesome way to make this happen. Another way is to reach out to community partners. When we are seeking out an opportunity, I will send the same email to multiple partners to see who is willing and able to partner with us in any way that they can. A lot of times, industry partners want to help. They just need to be asked directly. Industry partners can also provide support if you are collecting materials or looking for donations. When we are seeking support, one thing that helps us to decipher between formal and informal technology integration needs. Formal integration happens during the regular teaching block. Informal integration occurs outside of the regular class time, such as clubs or special events. By separating computer science needs into these 2 categories, it can help teachers in their communications of expectations and needs as they reach out to selected partners when they're seeking resources.
Okay, now we're going to take a look at some real life examples of exploring technology across our schools. So first and foremost, we use a lot of Legos. Legos may not be considered an actual form of technology, but Legos are super versatile in any type of STEM instruction. You've got learning concepts like computational thinking, coding, and really students will just kind of hone in on 21st century skills. You can do a lot with patterns and a lot of different other things that involve collaboration, communication, and creativity. So these provide a way for many types of emerging skills, problem solving, spatial skills, semi-complex tasks. And we found that Legos are really used among any of the grade levels, even the kids at our middle school level enjoy exploring with Legos. They're three-dimensional, and they really just provide students a lot of leeway to kind of just explore at their own pace.
And because most students probably already have experience with Legos or their similar building blocks, it makes it very approachable way for them to experience computer science. The next type of material we're going to talk about are BeeBots. These are a type of robot that are perfect for teaching control, directional language, and programming. With these bee-shaped robots, students press directional codes into the bee, very similar to the motion of pressing buttons into a calculator or a remote. And these robots do not require additional technology to make them work, such as an iPad or a tablet. Their bee-shaped appearance also makes the perfect opportunity to make computer science embedded into life science lessons as teachers are building BeeBots into their computer science culture. Across our schools, teachers use a variety of different interactive teaching boards. Most of these are box lights. Our box lights are interactive touchboard panels that allow teachers to write. They display, project content, screencasts. They can share sound, basically do any type of, they can feature all sorts of digital learning material for students. Almost every single one of our classrooms across all of our 4 schools have a box light in them. Box lights really are the heart of our instruction for our teachers. And as you will find in our middle and high school levels, box lights are not just used for teachers, but they are used among our middle and high school students as well. Also, we have a variety of digital display TVs across our schools. These are featured mostly at our high school and middle school level. These are used as a digital signage to display important information, such as schedule and announcements. Our middle and high school are very unique in the sense that you have 2 schools in one building. So it's really important that when our visitors visit the building, it kind of helps them stay informed on what's going on. That way, each school is uniquely represented is a part of their culture. So these are often used to showcase student work with pictures, videos, and shout outs, and they do take the place of a traditional projector. And you will find them mostly at our high and middle school level, but our preschool level also uses display TVs to host instructional content. Wonder Dash robots were the first robots that I had experience with as a classroom teacher. They do require a tablet with internet access to make them work, which can be an obstacle as you're building these into your classroom. These robots are super fun and truly full of character, and kids love using these robots. They are relatively manageable and make a really good first robot for teachers who are looking to bring robots into their classroom in a very fun, lighthearted way. There are add-ons you can get, such as musical instruments and catapults, that can provide a very easy overlap to embed computer science into other subject areas, such as music and physical science. Another one of the robots that we frequently use are called Botleys. These are 2.0, the coding robot. So they help kids learn to code basically through 100% screen-free play. They know multiple ways to code right out of the box, so you don't need any additional iPads or gadgets. They come with a set of instructions. You can code the Botley to move in 6 different directions. They play music, and they will even put on a light show. They're highly interactive and engaging. QUBO Coding Plus are a fun tabletop computer science tool. Each set comes with a total of 82 tag tiles to use with your QUBO robot and activity maps. So the tiles, which are snapped together very similar to the pieces of a puzzle, allow basic control of movements, time, speed, distance, and direction as the students are putting the puzzle pieces together. Students have endless possibilities to develop increasingly complex programs using the basic movements, functions, subroutines, and loops through the tile pieces. Across our schools, students use Chromebooks.
Chromebooks are used starting in first grade all the way up into 8th grade. So what you see here is a picture of our students in action using Chromebooks. We are Google schools, so we use Google Classroom in combination with those Chromebooks. And then as our students move into the high school level, our students use full laptops.
Sphero Bolts are spherical programmable 8x8 light matrix spheres that open up an endless array of coding and gaming capabilities. Students use a tablet to access one of the Sphero Bolt apps that allow advanced sensors to track speed, acceleration, and direction and drive without having to aim at the robots. These bots also feature infrared communication, allowing the robots to talk to the other Sphero Bolt robots, change colors, and collect data. The support through Sphero offers extremely inclusive lesson plans and materials for teachers to use in the classrooms to build that culture.
So as Betsy mentioned, we do use a combination of tablets. Now, as mentioned previously, our students do use Chromebooks and they are assigned one-to-one with those devices. However, with our tablets, our students are not assigned one-to-one. We have approximately 36 tablets across our schools that we use in combination for different interactive computer science activities. But here, the students are using tablets to facilitate some of our coding bots. Here are some pictures of tech in action across our schools. So you'll see Girls Who Code, they work once a week in our extended learning program where they work with me. We work from a program called Scratch. We also work a little bit in code.org. These are both free programs that provide coding activities. Girls Who Code also has an entire platform that's totally free, and they also provide students with a lot of free swag. On the Girls Who Code platform, they can learn a variety of skills. They also have it's not just computer science where it's digital, but they also have a lot of unplugged activities that allow for a lot of really good hands-on instruction for our girls. On the right side of the screen, you'll see the University Middle Tech Team. The University Middle Tech Team is a club that meets approximately twice a month. In this team, students developed their own tech ticket system. So students can submit repairs for a tech ticket that they might need, whether it's a question or their device broke and they're in need of repair. And then the tech team facilitates the repair process for that. Now, while they don't actually do the repairs themselves, they have been trained to troubleshoot basic ideas, change out batteries, and do very basic entry-level skills. And in addition to that, they help partner with our ITS program that we have on campus. And then they've learned a lot about ITS jobs and how they relate to the real world. And then on the very far right, it's just another Girls Who Code in action, playing with some of our robots. And so we try to expose the students to both sitting at a computer and learning, as well as getting up and moving around and learning at the same time.
Referencing the computer science standards is a really important place to start when analyzing computer science practices in your classroom. Once you have lesson ideas in mind, reach out to your local STEM hubs to see if they have the materials you are seeking for you to borrow. We rely heavily on the West Tennessee STEM Hub to borrow robots and materials and provide STEM ambassadors for support to build our computer science cultures across our K-12 university schools compendium.
In addition to that, because we are Google schools, we do use a lot of Google applied skills, which are exclusively taught at the middle school and high school level. We also have a lot of grants for technology. We're always digging to figure out how we can add more to our supply. We use a lot of Nearpod, Gizmos, Code.org programs, basically any program that's going to provide a free platform for our students. And then Boxlight, Mimeo Boxlight is a preferred vendor, and that's where we get our box lights from that really are the heart of our instruction for our teachers. Thanks so much for tuning in.